Welcome to Sleepy Scientist Stories. Tonight's film follows an ancient celestial dance that has stirred imagination for millennia. What if the blood-red moon were more than shadow and light? What if it carried quiet messages about the balance that keeps a world alive? As Earth's shadow climbs the lunar face, the crimson glow reveals a lens made of air, white sunlight bent through hundreds of miles of atmosphere, edited by ozone and water vapor, then cast across 250,000 miles of night. Each eclipse becomes a soft disclosure of orbital precision and atmospheric breath, a reminder that conditions for life live in narrow margins of tilt, distance, and time. Long before modern instruments, fear met wonder beneath scarlet moons. The message was never prophecy, but physics. In this light, a story unfolds about cycles and beginnings, drift and duration, and the patient machinery of a system that has been ticking since the solar system was young. The moon drifts endlessly through space, circling Earth as it has for billions of years, locked in a quiet gravitational embrace. To the casual observer, it is a constant companion, silver and steady, rising and setting with dependable rhythm. Yet hidden within its path is a secret alignment, a rare geometry that transforms the familiar orb into something extraordinary. When the sun, earth, and moon fall into a perfect line, the stage is set for one of the most poetic spectacles the universe offers, the lunar eclipse. Earth, massive compared to its smaller satellite, casts a shadow that stretches nearly 1,000,000 miles into space. This shadow is shaped like a great cone, its wide base beginning at our planet and tapering into the dark beyond. Most of the time, the moon sails slightly above or below this shadow, its tilted orbit carrying it safely past the invisible geometry. But a few times each year, the orbits align. Slowly, almost imperceptibly at first, the moon drifts into the outer portion of that shadow, the penumbra. Here, sunlight is only partly blocked, and the lunar face begins to dim. To untrained eyes, the change may seem trivial, but sensitive watchers, whether ancient or modern, know it is the first whisper of transformation. Civilizations that lived beneath this sky long before telescopes and computers felt awe and fear when the bright lunar disk began to fade. In China, scribes described it as a celestial dragon devouring the moon. In the Americas, stories spoke of jaguars leaping skyward to take bites out of lunar light. To many, it seemed as though the universe itself had turned against the night, swallowing one of its most trusted beacons. Yet what they witnessed was not chaos but cosmic order, the precise mechanics of gravity and motion, written in shadow across the heavens. The penumbra grows darker as the moon slips deeper into Earth's shadow. Then, as it reaches the umbra, where no direct sunlight can pass, the spectacle takes on its most dramatic form. The moon should disappear completely in blackness, and yet it does not. Instead, its surface glows with an otherworldly light, first dim, then gradually blooming into shades of copper, rust, and fire. This is no trick of imagination, but the result of Earth's own atmosphere. Sunlight bends as it passes through the air that surrounds our planet, scattering blues and greens, while reds curve across space to bathe the moon in their glow. The moon, in that moment, becomes a canvas painted by Earth's breath. The dance of shadows reveals more than beauty. It offers evidence. Aristotle, in ancient Greece, noticed that Earth's shadow always curved as it crossed the moon, proving our planet was round centuries before sailors circled the globe. Astronomers since then have used eclipses to measure distances, refine models of celestial motion, and understand the fragile layer of gases that makes Earth habitable. Yet beyond science, there remains something timeless. To watch the moon darken, then glow as though set aflame, is to feel part of a story written long before humans could read the stars. It is to stand in the quiet of night and witness proof that we live in a universe governed by both precision and poetry. And so the dance begins, shadows stretching, light bending, myths awakening, reminding us that even in darkness, the cosmos speaks with beauty too vast for words. As the eclipse deepens, the moon drifts fully into Earth's umbra, the dark heart of the shadow where sunlight cannot directly reach. By all logic, it should vanish from the sky, swallowed in darkness, leaving nothing but a blank void where the familiar silver orb once glowed. Yet nature writes a different story. Instead of disappearing, the moon is reborn in color, glowing like an ember in the ashes of night. It turns copper, rust, crimson, sometimes deep burgundy, the blood moon that has haunted human imagination for millennia. This transformation is not illusion. It is physics at its most elegant. Around the curve of Earth, the sun still shines. Its light streaming toward the night side of our world encounters a fragile veil of gases, nitrogen, oxygen, water vapor, and countless particles that make up our thin atmosphere. These molecules scatter sunlight, filtering and bending it. Shorter wavelengths, blue and violet, are scattered away, painting Earth's daytime sky in cerulean. But longer wavelengths, orange and red, curve through the atmosphere, bending around the planet's limb. This refracted light spills into the shadow and travels across 250,000 miles of empty space to bathe the moon. Every blood moon is therefore painted, not by the moon itself, but by Earth. It is sunlight filtered through the collective breath of our world. The air that carries storm clouds, mist and winds also acts as a cosmic lens. Every sunrise and every sunset, occurring along the rim of Earth at that moment, contributes to the glow. When the moon turns copper, it is wearing the light of countless horizons, thousands of dawns and dusks, stitched together and projected into space. The exact shade of an eclipsed moon depends on the condition of Earth's atmosphere. A clear sky lets more light through, producing a bright orange or fiery red. After massive volcanic eruptions, when ash and sulfur hang in the stratosphere, eclipses grow dark and foreboding, the moon dimming to near invisibility. In 1883, following Krakatoa's eruption, lunar eclipses were so blackened that observers struggled to see the moon at all. The celestial lantern had become a shadow of grief, carrying Earth's trauma across the heavens. Astronomers today measure this glow with instruments, turning beauty into data. Spectroscopy reveals the fingerprints of gases, ozone absorbing ultraviolet, carbon dioxide etching infrared, water vapor leaving its marks as well. Each eclipse becomes an accidental experiment in atmospheric chemistry. The moon, in that instant, is Earth's mirror, reflecting not only filtered sunlight, but the state of the air we breathe. For ancient peoples, none of this was known. To them, the blood moon was a sign of battle, famine, or divine anger. Cultures recorded crimson moons as omens, shaping rituals to ward off disaster. Yet in their fear they captured truth. The blood moon is a warning, not from gods, but from nature. It shows how delicate our atmosphere is, how easily its balance can shift, how profoundly Earth and moon are bound in light and shadow. And still, beyond science and fear, the copper moon remains a spectacle of sheer beauty. To see it glowing above mountains, oceans, or deserts is to watch the ordinary transformed into the extraordinary, the familiar into the surreal. It is the universe reminding us that even shadows hold fire, and even darkness can shine. Thus, the pale moon becomes copper, wearing Earth's breath like a cloak of flame, a lantern of shadow rising in the silence of night. The copper glow of an eclipsed moon is more than spectacle. It is evidence, a record of the invisible air that surrounds Earth. Each blood moon becomes a silent experiment, revealing the chemistry and clarity of the atmosphere in that exact moment. What appears to the eye as beauty is, to science, a coded message written in light. When sunlight passes through Earth's atmosphere, it is scattered, bent, and filtered. Molecules of nitrogen and oxygen break apart the blue and violet wavelengths, scattering them across the sky. This is why our days are blue, painted by the endless scattering of short light. But during an eclipse, the moon receives only the colors that survive the journey, reds, oranges, and deep coppers that slip through the atmosphere like whispered secrets. This bending of light, known as refraction, turns the whole Earth into a cosmic lens. The curved atmosphere focuses the red spectrum, funneling it into the shadow where the moon drifts. The glow is delicate, easily changed by what the air contains. If Earth's atmosphere is clear, the moon blazes bright orange, glowing like molten metal in a forge. But when the skies are filled with dust or ash, the moon dims, its fire choked to a faint ember. History remembers these changes. After the eruption of Krakatoa in 1883, observers described lunar eclipses as nearly invisible, so dark that the moon seemed erased from the heavens. A decade later, Tambora's eruption in 1815 left similar marks, dimming blood moons across the world. Even without satellites or telescopes, ancient observers recorded these eerie skies. Chinese court astronomers noted when eclipses were unusually dark, and European monks wrote of moons that looked like dying coals. Today, scientists reread those records as data, recognizing them as eyewitness accounts of volcanic events and atmospheric shifts. Modern instruments now capture these details with precision. Spectrometers, trained on the eclipsed moon, dissect its glow into wavelengths. Within that spectrum are signatures: ozone-absorbing ultraviolet, water vapor shaping the reds, carbon dioxide subtly altering the light. Astronomers can detect the health of the atmosphere by studying the moon's reflected face. A blood moon, then, is not just art for the eye, it is science for the mind, a planetary health check written in photons. The alchemy of atmosphere extends to every corner of Earth. Fires burning in forests, dust storms sweeping across deserts, smoke rising from human industry, all leave their fingerprints in eclipse light. The moon becomes a mirror of our collective breath, showing how deeply connected Earth and sky truly are. Each shade of crimson is unique, never repeated, for the state of the air is always changing. To poets, this transformation is magic, a pale silver lantern turned to copper flame. To scientists, it is physics, scattering, refraction, absorption. Yet the two are not separate. Both views describe the same truth, that the air we depend upon for life reaches across space to paint the moon. In those crimson hues lies the story of Earth itself, fragile, ever-changing, yet endlessly capable of turning shadow into light. Atmospheric alchemy transforms darkness into color, shadow into fire, and silence into story. Every blood moon is Earth speaking in crimson, its breath painted across the face of its ancient companion. Lunar eclipses might feel like rare accidents of the cosmos, fleeting moments when three worlds happen to align. But behind the wonder lies a deeper order, a rhythm that beats steadily through centuries. Like the pulse of a hidden heart, eclipses return in patterns, predictable, measurable, eternal. This pattern is called the Saros cycle, an elegant symmetry of time. Every 18 years, 11 days, and 8 hours, the Earth, Moon, and Sun fall into nearly the same alignment, and the shadow play begins again. Each eclipse belongs to a vast family stretching across more than a millennium, generations of crimson moons born, growing, fading, and eventually dying. These cycles are invisible to casual eyes, but were discovered long ago by patient watchers who mapped the sky with nothing more than memory, stone, and ink. The Babylonians, thousands of years ago, first recognized this rhythm. They noticed that eclipses returned, not randomly, but on schedule. Without computers or telescopes, they found the hidden metronome of the heavens. Armed with this knowledge, they could predict eclipses, turning what had been omens of fear into instruments of power. Priests could tell kings when the moon would turn red, lending authority to their visions and anchoring human history to celestial precision. But why 18 years? The answer lies in the harmony of cycles. The moon circles Earth every 29.5 days, completing its phases. It returns to the same point in its elliptical orbit every 27.3 days, and it crosses the plane of Earth's orbit every 27.2 days. These rhythms are close, but not identical. Only after 223 lunar months do they realign almost perfectly. That is the Saros. The extra 8 hours shift each eclipse westward across the globe, so that over centuries the crimson shadow migrates across continents, touching new lands before the family ends. Each Saros series begins quietly, with faint partial eclipses near Earth's poles. As centuries pass, the geometry tightens, and total eclipses blossom in full glory near the equator. Then, just as gradually, the sequence wanes. After 1,000 years or more, the family fades back into partial shadows before disappearing entirely. Each series is like a life cycle, a cosmic lineage written in shadow and light. Modern astronomy confirms what ancient wisdom revealed. We can predict eclipses far into the future, charting their rise and fall across centuries. Computers simulate alignments for thousands of years, proving that the heavens follow laws as strict as mathematics and as graceful as poetry. The shadow's return is not chance, it is inevitability, encoded in the orbits of worlds. And so, every blood moon is both unique and connected, a single bead in a long string that stretches across time. The eclipse seen by a Babylonian farmer belongs to the same family as one watched today, and one that will glow for generations yet unborn. In the Saros, humanity is linked to the past and the future, bound by cycles older than civilization itself. The rhythm of return is the universe keeping time, marking centuries not with clocks or calendars, but with shadows crossing the moon, reminders that amid change and chaos, some patterns endure forever. Every eclipse is not only an event of the present, it is also the arrival of light that has travelled on extraordinary journeys. The glow painting the moon red tonight began in the sun's heart thousands, even millions of years ago. Deep in its core, hydrogen atoms fused into helium under pressures so immense that mountains would collapse like dust. That fusion released photons, but these particles of light did not fly out at once. Instead, they bounced endlessly within the sun's dense interior, scattering like restless wanderers in a crowded hall. Only after eons did they escape into open space, racing across the solar system at 186,000 miles per second. 8 minutes before they reached Earth, they left the sun's surface as ordinary sunlight. But during an eclipse, their destiny changes. The planet intercepts them, and they encounter the fragile envelope of gases that make Earth unique. Molecules scatter them, filter them, bend them. The blues vanish, the reds survive. In that bending, light is transformed, sunlight altered by Earth's air, reborn as a crimson stream. This light then crosses the void to the moon, 240,000 miles away. It touches cratered highlands and ancient lava plains, scattering from powdery regolith that has not changed for billions of years. Some of it reflects softly, some more brightly, depending on the terrain. Then it begins its return journey, bouncing back toward Earth, carrying within it a record of everywhere it has been. The photons that finally meet an observer's eye during a blood moon are messengers. They tell stories of fusion fires in the sun's core. They tell of the condition of Earth's atmosphere, its clarity or its ash, its dust or its pollution. They tell of the moon's geology, its mountains, plains, and fine dust. Within a single crimson glow are the layered histories of 3 worlds: the sun, the earth, and the moon. For ancient people, this was unknowable, yet even without science, they intuited the moon's red light carried messages. Priests, astronomers, and storytellers recorded eclipses, believing them to be signs of fate. In their way, they were right. The eclipsed moon does contain messages, not divine prophecy, but physical truth written in wavelengths. Today, with instruments, we decode what they glimpsed with awe. Spectroscopes split that crimson glow into rainbows. Within those rainbows are fingerprints, lines where gases have absorbed certain wavelengths. Ozone marks its presence, carbon dioxide leaves its trace, water vapor carves its signature. Each eclipse then becomes a report on Earth's breath, as if our atmosphere were writing letters in light and sending them to the moon for delivery back to us. The poetic truth is this: when we watch a blood moon, we are not only seeing the moon, we are seeing the sun's ancient fire, filtered through Earth's living air, reflected by lunar dust, and returned as a single, glowing message across time. The sky becomes a book, the moon its page, and light the ink that carries knowledge. In every crimson eclipse, ancient light whispers, the sun is alive, the earth is fragile, the moon remembers. To watch it glow is to read messages written in photons, stories carried across space and time. The story of eclipses is not just about the moon's orbit or Earth's shadow. It is also about the way our planet itself leans into space. Earth does not spin upright. Its axis is tilted 23.5 degrees, forever pointing toward the same patch of stars. This lean, a scar from a colossal collision billions of years ago, shaped the rhythm of our seasons and set the stage for eclipses. Without it, the sky would be very different. Imagine if Earth stood straight, with no tilt at all. The moon's path would line up perfectly with Earth's shadow each month, and lunar eclipses would become routine. Every full moon would dim to copper, and the spectacle would lose its rarity, its power to inspire awe. Now, imagine the opposite. If Earth leaned far more, say, 45 degrees or beyond, the geometry would shift so dramatically that the moon might never pass through Earth's shadow, robbing the sky of eclipses altogether. Our actual tilt, balance between these extremes, creates something extraordinary. It ensures that eclipses are neither too frequent nor too rare. They appear a handful of times each year, often invisible from certain continents, sometimes partial, sometimes total, always unpredictable enough to feel like a gift. The tilt, in partnership with the moon's slightly inclined orbit, makes eclipses precious events, scattered like rare jewels across the calendar of time. This tilt tells a violent origin story. Scientists believe a Mars-sized body known as Theia slammed into the young Earth 4.5 billion years ago. The collision nearly tore our planet apart. Debris thrown into orbit eventually coalesced into the moon, while the Earth, scarred from impact, settled into its tilted spin. That ancient disaster still echoes in every eclipse, for without Theia, Earth might spin upright, and the moon itself might not exist. The blood moons we marvel at today are children of that cosmic catastrophe. The tilt shapes more than eclipses. It shapes life. Because of it, sunlight shifts across hemispheres, giving us summer and winter, planting and harvest, cycles of growth and rest. Without seasons, Earth might not host the diversity of life we know. In this way, eclipses are tied not just to orbital mechanics, but to the flourishing of forests, oceans, and civilizations. The copper glow of the moon is connected by geometry to the tilt that brings blossoms in spring and snow in winter. Every eclipse is therefore a reminder of balance, a world tilted just enough to stir its seasons, a moon inclined just enough to sometimes fall into shadow, a sun steady enough to paint it all in light. The universe feels chaotic, yet hidden within it are delicate alignments that make beauty possible. When Earth's shadow bends across the lunar face, it is not only a play of light. It is the tilted memory of an ancient collision, the scar of creation turned into symmetry. It is the reminder that from cosmic violence came harmony, and from randomness came rhythm. On this tilted stage, the moon performs its crimson dance, and every shadow crossing its face is a silent echo of the day. Two worlds collided to make the Earth we know. The moon feels eternal when seen from Earth, a pale disk that rises each evening with timeless calm, guiding tides and lighting paths. Yet even this steadfast companion is not fixed. Slowly, silently, it is leaving us. Each year the moon drifts about 3.8 centimeters farther away, a distance small enough to measure with lasers yet monumental across geological time. This quiet retreat reshapes the relationship between Earth and its satellite, altering the very eclipses we marvel at tonight. The cause of this wandering lies in tides. The moon pulls on Earth's oceans, lifting vast bulges of water that shift as our planet rotates. But Earth spins faster than the moon orbits. That mismatch means the tidal bulges lead slightly ahead of the moon in its path. Gravity tugs between them, and the effect is curious. Earth's rotation slows, losing tiny fragments of energy, while the moon gains speed, spiraling outward. What feels like stillness is actually a trade of motion, a subtle exchange written into every wave that breaks on every shore. This recession carries profound consequences. Billions of years ago, when the moon was much closer, it loomed enormous in the sky, 3 times its current size. Nights then were brighter, tides stronger, days shorter. A full day on Earth lasted only 5 hours. Eclipses in those ancient skies must have been breathtaking, lasting far longer, painting the heavens with vast shadows of fire. The moon's copper glow would have dominated primitive landscapes, illuminating seas where life itself was learning to stir. Over time, as the moon recedes, the geometry of eclipses evolves. Today's total eclipses last for hours, but in the far future they will shorten. The moon, smaller in the sky as it drifts outward, will pass through Earth's umbra more quickly. Still farther in time, it may become too distant for Earth's shadow to engulf it fully, dimming eclipses into partial events. The beauty we witness now exists only in a narrow chapter of cosmic history. The wandering moon also reshapes Earth. As energy flows outward, our rotation slows. Days lengthen, only by milliseconds per century, but steadily. In hundreds of millions of years, Earth's day will stretch to 30 hours. The clocks of civilizations will change, yet the rhythm will remain tied to the same tidal dance, invisible yet relentless. Astronomers track this retreat with extraordinary precision. Reflectors placed on the moon by Apollo astronauts still bounce back laser pulses, measuring distance to within a centimeter. Each reading confirms the slow goodbye, each photon of light crossing the void to mark how far the moon has wandered since humans first looked up in wonder. But if the moon is leaving, what does that mean for eclipses? Unlike solar eclipses, which depend on the moon's exact size in our sky, lunar eclipses will endure for billions of years. Earth's shadow stretches wide, easily large enough to capture the retreating moon. The changes will be gradual, shorter totalities, paler hues, but the crimson lantern will still rise for future skies. Solar eclipses, however, will not survive. In about 600 million years, the moon will appear too small to cover the sun completely. Humanity, or whatever life endures then, will never see the breathtaking sight of a perfect solar eclipse. The cosmic coincidence that allows it is fleeting, as fragile as it is beautiful. The wandering moon is thus a lesson in impermanence. We live in a rare window of history when eclipses are grand, dramatic, and deeply moving. In the deep past, they were vaster. In the deep future, they will fade. The moon itself is a record of time's patience, drifting outward as if pulled by the horizon of eternity. Each blood moon we witness is a reminder of this slow farewell, a performance repeated only in this era, during this fleeting chapter of cosmic history. The moon drifts away, carrying with it the memory of tides, the echoes of ancient seas, and the promise that even companions in the sky cannot stay forever. When the moon turns red, it does so not for a single place, but for half the world at once. Unlike solar eclipses, which carve narrow paths of darkness across continents, lunar eclipses belong to entire hemispheres. Wherever night has fallen, eyes can lift to see the same copper disk glowing in silence. This simultaneity creates something rare in human history, a moment when billions can share one sky, one sight, one story. Picture a single blood moon rising over Earth. In Tokyo, office towers and neon signs are dimmed by its glow as families gather on rooftops to watch. In Cairo, the crimson moon hangs above the pyramids, the same light once watched by ancient priests. In the Amazon rainforest, rivers mirror the glow, reflecting copper skies onto silent waters. Across deserts, mountains, oceans, and sprawling cities, humanity is united by the same transformation. Every culture may tell its own story, yet the shadow belongs to all. Throughout history, this shared sight has carried profound meaning. Indigenous peoples of the Americas spoke of jaguars or serpents devouring the moon, while Chinese astronomers wrote of celestial dragons. Viking sagas told of wolves chasing the lunar disk, while in Africa, the blood moon was a time of ritual and song. Each culture saw something different, but the experience itself was universal. The same crimson light fell on all, linking human imagination across distance and time. This unity has not faded. In 2014, during a widely visible total eclipse, millions across continents looked skyward at once, sharing photographs online within minutes. From South America to Australia, from Europe to Africa, identical images flooded screens, turning the blood moon into a global event. The myths had changed, but the wonder remained. In place of fires and drums, hashtags and live streams carried the eclipse across the globe. The blood moon is democratic. It plays no favourites among nations or classes, rich or poor. The same shadow stretches over villages and skyscrapers alike. A shepherd in the Andes and a scientist with a telescope in California see the same copper glow. The experience unites without boundaries, reminding us of something often forgotten. Beneath divisions of language, culture, and belief, we all live beneath the same sky. Science deepens this sense of unity. The photons painting the moon red pass through Earth's atmosphere as a whole. They bend through the same veil of air that belongs equally to all life. Every breath taken by forests, oceans, and cities contributes, in some subtle way, to the exact shade of the eclipse. The moon is not only shared by observers, it is painted by the collective atmosphere of a single living planet. And yet, within this universality lies individuality. No two blood moons are identical. The tint of crimson, the brightness of the glow, the sharpness of the shadow, all are shaped by conditions unique to that night. Dust from deserts, smoke from fires, or ash from eruptions shift the color palette. Every eclipse becomes a singular performance, uniting billions in a moment that will never occur again. This duality, shared yet unique, timeless yet fleeting, makes eclipses more than celestial mechanics. They are communal experiences etched into memory. Families remember the night the moon turned red. Nations record them in chronicles. Scientists preserve them in data. Each blood moon becomes part of a shared archive of wonder, stretching from stone temples to digital archives, from ancient chants to live-stream feeds. When cities fall beneath the shadow, the world is briefly reminded of its unity. The moon turns red, and in that glow lies a truth deeper than myth or science, that humanity is one species, living beneath one sky, forever bound by the shadows that pass across it. For much of human history, the blood moon was not a symbol of beauty, but of dread. To see the familiar silver lantern dim and glow as if wounded in fire was to feel the universe itself shifting into danger. Civilizations across the globe gave names to this terror, clothing it in myths and stories to make sense of the unexplainable. And in those myths, the moon was never alone. It was always under attack. In ancient China, scribes wrote of a celestial dragon rising from the void to devour the lunar orb. During eclipses, villagers beat drums, rang bells, and shouted into the night to scare the dragon away, believing their noise could rescue the moon from its jaws. In the Americas, some peoples believed a jaguar was leaping into the sky to bite the moon. The copper glow, they said, was the blood of the beast's prey dripping across the heavens. In Norse mythology, wolves named Skjold and Hati chased the sun and moon through the sky, and during an eclipse one of them was thought to have caught its quarry. Fear shaped behaviour. Emperors fasted, armies halted campaigns. Priests performed rituals to calm the skies. The red moon was omen, prophecy, warning. Farmers wondered if crops would fail. Rulers saw signs of betrayal or war. Even in the Mediterranean, as empires rose and fell, crimson eclipses were interpreted as divine judgment, their timing woven into chronicles as markers of fate. Yet alongside fear grew a parallel thread: curiosity. In Greece, philosophers began to notice patterns. Anaxagoras in the 5th century BCE dared to suggest that eclipses were caused by Earth's shadow crossing the moon. Aristotle observed that the shadow was always curved, no matter the moon's position in the sky. Evidence, he argued, that Earth was a sphere, not flat. Slowly, terror gave way to logic, and logic to science. Still, fear never vanished entirely. In 1504, stranded in Jamaica, Christopher Columbus used his knowledge of an upcoming eclipse to frighten the indigenous people. He claimed his god would darken the moon in anger if they did not provide supplies. When the blood moon rose on cue, their fear gave him power. Even in the age of exploration, crimson eclipses could still be wielded as tools of awe and control. The journey from fear to wonder mirrors humanity's path through knowledge itself. What once terrified became predictable, measurable, and eventually celebratory. Today, millions gather not to pray in fear but to share awe, setting up telescopes in parks, photographing the phases, live streaming the event to distant continents. Where once blood moons divided empires with omens, they now unite the world in shared fascination. And yet, awe remains as strong as ever. To see the moon turn red is still unsettling in a primal way. Crowds fall silent, breaths slow, eyes widen. We understand the physics, the scattering of light, the geometry of shadows. But knowledge does not dull the wonder, it deepens it. The blood moon becomes both mystery and explanation, myth and measurement, fear and fascination. Science has revealed details that mythology only hinted at. The moon glows red, not with its own blood, but with the filtered breath of Earth. The devouring is not by dragon or jaguar, but by shadow, cast with perfect precision. The omen is not divine anger, but atmospheric truth. Yet the feeling in the heart is the same, a stirring that life is fragile, that the cosmos is vast, that beauty can be tinged with unease. The fear and wonder of eclipses are not opposites, but companions. Together they remind us that the universe is both knowable and untamed, that even when explained, it can still feel like magic written in the sky. For thousands of years, the blood moon was explained by myth, feared as omen, or celebrated as ritual. But in the 17th century, a new instrument changed everything. A simple tube of glass and wood, fitted with curved lenses, opened a window through which humanity could finally see the heavens with clarity unknown to any earlier age. The telescope became not only a tool of science, but a gift of vision, allowing eclipses to be studied in detail that once belonged only to the gods. When Galileo Galilei first turned his telescope to the moon, he saw what no eye had ever seen before: mountains, valleys, craters, terrain as rugged as Earth itself. During an eclipse, he noticed something extraordinary. Even when the moon was fully immersed in Earth's shadow, it did not vanish. Its surface glowed faintly red, revealing that some mysterious force was bending sunlight around Earth. Galileo could not yet explain refraction in detail, but his drawings recorded the truth. The blood moon was not disappearance, but transformation. Over the centuries, telescopes grew in power. Newton refined their design with mirrors instead of lenses, eliminating distortions. Astronomers in the 18th and 19th centuries used these improved instruments to time eclipses with precision, noting the moments when shadows crossed specific craters and peaks. They discovered that the shadow was not a simple edge but a gradient, shaped by Earth's atmosphere. The telescope revealed that eclipses were not just alignments. They were experiments in optics, where the air itself became part of the show. By the 19th century, another advance transformed telescopic observation: spectroscopy. With prisms and slits, astronomers could split the crimson glow into its spectrum, revealing dark absorption lines where gases had filtered light. Oxygen, ozone, carbon dioxide, water vapor, each left a signature in the spectrum of eclipse light. Through telescopes, the moon became a mirror, not only of Earth's shadow, but of Earth's chemistry. Each eclipse turned into an atmospheric survey, showing scientists what air lay above forests, cities, and oceans at that moment in time. Telescopes also deepened cultural wonder. In cities across Europe and America, public gatherings formed during eclipses, where astronomers invited crowds to look through their instruments. Children and labourers, aristocrats and scholars, all lined up to see the copper moon magnified before their eyes. For many, it was the first time the heavens felt within reach, no longer distant or divine, but part of a shared universe that could be observed, measured, and understood. The 20th century expanded this gift further. Photography was joined to telescopes, capturing detailed sequences of eclipses across time. Later, spacecraft left Earth entirely, turning telescopes outward. From orbit, the Hubble Space Telescope observed Earth's shadow from afar, watching as refracted sunlight formed a halo around the planet during an eclipse. What Galileo had glimpsed as mystery was now seen from space itself, Earth glowing like a lantern, bending sunlight to paint the moon red. Today, digital telescopes and sensitive detectors continue this legacy. Amateur astronomers with modest equipment can capture images once reserved for professionals. Sophisticated observatories measure eclipse spectra so finely that they can track volcanic eruptions, pollution, and even subtle shifts in atmospheric circulation. Eclipses have become tools not just of wonder, but of planetary health, revealing Earth's breadth to anyone who cares to look. And yet, beyond all science, the telescope has preserved the soul of the eclipse. To look through one at the copper moon is to bridge myth and measurement, to see not only the shadow but the story it tells. The telescope gave humanity proof, but it did not take away poetry. It only made the wonder sharper. The telescope's gift is not only vision but connection, a way to see eclipses as both cosmic event and earthly message, both experiment and art, forever uniting precision with awe beneath the red glow of shadowed light. Before the invention of cameras, eclipses were fleeting guests. A blood moon might ignite the sky with crimson fire, stir entire kingdoms with awe or fear, and then vanish, leaving only memory. Ancient observers recorded them in poetry, drawings, and chronicles. Yet these records, no matter how vivid, could never truly capture the subtle hues, the fading of silver into copper, the dark gradations across craters and valleys. The eclipse lived only in the hearts of those who saw it, fading as quickly as the shadow itself. That changed in the 19th century. On July 28, 1851, John Adams Whipple pointed his camera at the eclipsed moon and captured the first successful photograph of a lunar eclipse. The image was blurred, the moon little more than a smudged disk of light, and yet it marked a revolution. For the first time, a moment that had always dissolved into memory was frozen in silver salts, preserved for generations beyond. The moon's transformation was no longer a secret shared only with the night sky. It was now a story that could be retold in light itself. Early eclipse photographers faced enormous challenges. Exposures were long, requiring patience and steady tracking as the moon moved slowly through shadow. Glass plates were fragile, chemicals unstable, and results uncertain. Yet each attempt brought progress. By the late 1800s, photographs revealed not just the shape of Earth's shadow, but also subtle differences in brightness across lunar terrain. Crater rims glowed faintly while lowlands dimmed more quickly. The moon was no longer just a symbol of myth but a laboratory for observation, preserved frame by frame. As technology advanced, so did memory. In the 20th century, film cameras allowed astronomers to capture entire sequences of eclipses. Time-lapse photography stitched together the moon's gradual transformation from silver to copper to deep red, showing in a single image what took hours to unfold. These images turned eclipses into narratives, arcs of light and shadow that told their own stories long after the night was over. Then came the digital age. With sensitive sensors and short exposures, cameras could now capture fine gradations of color invisible to the naked eye. The crimson glow revealed itself in shades of orange, copper, and burgundy, each layer tied to the filtering of Earth's atmosphere. Photographers could enhance detail, showing how volcanic dust, city pollution, or seasonal clarity painted the moon differently each time. What once demanded trained astronomers now belonged to anyone with a telescope, a tripod, and patience. The blood moon had become both science and art, shared across the globe. Spacecraft took photography beyond Earth entirely. The Lunar Reconnaissance Orbiter, circling the moon, has captured images of Earth's shadow sweeping across the lunar surface. From its vantage, eclipses are not distant spectacles but immediate events, shadows racing at thousands of miles per hour across craters and mountains. NASA's satellites looking back at Earth during eclipses see something stranger still, a glowing halo of red light circling the planet, the very illumination that paints the moon crimson. What Galileo first noted through his telescope is now captured in photographs from space, proof of Earth's atmosphere bending sunlight across cosmic distances. Photography also democratized eclipses. Ancient kings and priests used them to inspire awe or control, but modern photographs belong to everyone. Shared instantly across social media, blood moons become global events. A child in Africa, a student in Europe, a traveler in South America, all can witness the same eclipse, captured and preserved in thousands of digital frames. The memory is no longer fragile, it is archived, duplicated, immortalized. And yet, beyond all science and technology, the photographs remain poetic. To see a time-lapse of an eclipse is to watch shadow devour light, then watch fire rise from darkness. To see a close-up photograph of the moon glowing copper is to glimpse both geology and atmosphere written in light. The images are both fact and metaphor, a reminder that beauty can be studied without being diminished. Photography's memory ensures that no blood moon is ever truly lost. Each one becomes a chapter in humanity's album of wonder, preserved in light so that future eyes may look back and see what the sky once whispered in crimson glow. The moon looks serene from Earth, pale, changeless, a steady lantern hanging in the dark. But beneath its calm surface lies a world of extremes. Unlike Earth, the moon has no atmosphere to cushion it, no oceans to absorb heat, no winds to carry warmth across its surface. It is a world exposed directly to the vacuum of space, where sunlight burns and shadow freezes. Nowhere is this truth more visible than during a lunar eclipse, when Earth's shadow sweeps across the lunar face and transforms it into a natural laboratory of temperature. In direct sunlight, the moon's surface bakes. Rocky plains known as Maria, the remnants of ancient lava flows, can reach 250 degrees Fahrenheit, hot enough to boil water in seconds. Crater walls glow with stored heat, and dust particles shimmer with radiation escaping back into space. Then, as the eclipse begins, that blazing furnace is extinguished. Earth's shadow moves over the surface, and in minutes the temperature plummets to nearly minus 200 degrees Fahrenheit. A swing of hundreds of degrees happens in silence across landscapes that have been frozen in time for billions of years. Astronomers study this dramatic cooling with infrared instruments. By measuring how quickly different regions of the moon lose heat, scientists can infer the properties of lunar soil and rock. Fine dust cools rapidly, while solid rock retains heat longer. Crater rims with their exposed bedrock glow faintly in thermal images even as lowlands fade to black. Each eclipse becomes a survey of geology conducted from afar, as if Earth's shadow were a probe mapping the moon's secrets. The Apollo missions added to this understanding. Astronauts left behind seismometers and reflectors, devices that help measure not only the moon's motion, but also how its surface interacts with heat and shadow. When Earth's eclipse shadow falls, these instruments reveal how quickly lunar regolith, powdered rock created by billions of years of meteorite impacts, responds to cooling. The results confirm what theory suggested. The moon is a place of extremes, a body without protection, where temperature swings are immediate and unforgiving. For Earth, this contrast is humbling. Our atmosphere and oceans buffer such extremes. When the sun sets, air and water hold warmth, softening the night. When dawn comes, they release it slowly, maintaining balance that makes life possible. The moon has no such comfort. It is a world naked to the cosmos, vulnerable to the simplest shadow. Each eclipse reminds us how delicate the conditions of habitability are. A thin veil of gases barely 60 miles thick is all that separates Earth's gentle nights from the moon's lethal cold. The blood moon's crimson light hides this violence. To the eye, it is beautiful, glowing like fire in darkness. But beneath that glow, temperatures are collapsing, rocks cracking under sudden stress, dust radiating heat into space. The eclipse is both poetry and physics, soft to us, severe to the moon. In the future, when humans return to live and work on the lunar surface, eclipses will not only be spectacles in the sky, but survival tests on the ground. Engineers will need to design habitats that endure these swings, machines that can function in both boiling heat and killing cold. The moon's silence hides a truth. Its environment is harsh beyond imagination. And yet, there is beauty in this fragility. The eclipse shows us, more than any other event, how the absence of atmosphere shapes a world. The moon reflects Earth's shadow, but also its difference, reminding us of what makes our planet rare. The temperature of shadows is not only a measurement, it is a contrast between barren rock and living world, between silence and breath, between a moon that freezes in shadow and an Earth that cradles life within its fragile warmth. A lunar eclipse is more than a spectacle of color, it is a clock written in shadow. The moon enters Earth's penumbra at a precise moment, slips into the umbra at another, and emerges again exactly on schedule. These timings are not vague approximations but accurate to the second. The heavens move with such precision that astronomers can predict eclipses thousands of years into the past or future. Each event is a marker in cosmic time, reminding us that while human lives rush forward with uncertainty, the dance of Earth, Moon and Sun keeps to rhythms that never falter. This truth was recognized long before modern science. In the 2nd century BCE, Hipparchus, the Greek astronomer, used the timings of eclipses to estimate the distance to the moon. By comparing when an eclipse was seen in different locations, he realized that the geometry of shadow could be turned into measurement. His answer, about 60 Earth radii, was astonishingly close to what modern instruments confirm. The eclipse became not only a wonder, but a ruler, stretching across the cosmos to map distances too vast to walk. Centuries later, astronomers refined this method. Edmund Halley, in the early 18th century, organized observers across Britain to record the 1715 solar eclipse. Their careful timing helped him refine Newton's theories of gravity and orbital motion. Lunar eclipses, though gentler, served the same purpose. By tracking exactly when Earth's shadow began to cross the moon, and when it left, astronomers could test the accuracy of their models of celestial mechanics. Each eclipse was like the ticking of a great cosmic clock, confirming that the laws of physics held true across the heavens. Today, the precision has only deepened. Atomic clocks allow scientists to record eclipse phases with accuracies measured in fractions of a millisecond. Combined with laser ranging experiments, beams fired at reflectors left by Apollo astronauts, astronomers track the moon's distance with centimeter precision. These data show that the moon is drifting away, that Earth's rotation is slowing, and that even the most eternal-seeming rhythms are subtly evolving. By comparing ancient records of eclipse timings with modern ones, scientists can measure how our planet and satellite have changed over thousands of years. The cosmos writes its history not only in craters and rocks, but in shadows and time. The predictability of eclipses also reveals something profound about the nature of the universe. It is lawful, ordered, comprehensible. The same mathematics that govern falling apples also dictate when the moon will turn red. Every shadow that creeps across its face obeys Newton's equations. Every curve of light bends according to the principles of refraction. To watch an eclipse on schedule is to see physical law embodied in beauty. And yet, there is mystery in this precision. We can predict exactly when the moon will be eclipsed centuries from now, but we cannot predict who will watch it, what stories they will tell, or even whether humanity will still be here. The timings are certain, but the witnesses are not. In this way, eclipses remind us of both permanence and impermanence. The clockwork of the cosmos will endure, while our presence is fragile and brief. Every blood moon, then, is a heartbeat of the universe. The penumbral touch is one tick, totality another, emergence yet another. Observers record, clocks confirm, and time marches on. But beyond the numbers lies something greater, the recognition that we live inside a cosmic mechanism vast enough to embrace centuries, delicate enough to be measured in seconds. In the crimson light of an eclipse, we see time itself unfolding, ordered, predictable, eternal. The moon becomes not only a lantern of shadow, but the hand of a great celestial clock, reminding us that the universe keeps time with shadows as surely as with stars. When Earth casts its shadow into space, it does not form a simple circle of darkness. Instead, the shadow stretches like a great cone, narrow at the tip, wide at its base. At the distance of the moon, this cone is vast, large enough to swallow our satellite whole, but within it lie two zones, the penumbra, where sunlight is only partially blocked, and the umbra, where no direct rays reach at all. The passage of the moon through these regions creates the stages of a lunar eclipse, the dimming, the bite of darkness, the total crimson glow. And yet, this shadow is not constant. It changes with time, with atmosphere, with geometry. In subtle ways, Earth's shadow is shrinking and growing, recording in silence the state of the planet that casts it. Ancient astronomers noticed the difference between penumbra and umbra without knowing why. To them, the gradual darkening was a puzzle. Why did the moon not vanish instantly? Today, we know the answer lies in Earth's atmosphere. The penumbra exists because sunlight bends and scatters, softening the edge of shadow. The umbra exists because eventually no direct rays can survive, but even that deep darkness is not absolute. Red light, refracted through thousands of miles of air, still curves around to paint the moon with its fiery glow. This dependence on atmosphere makes Earth's shadow a sensitive tool. When volcanic eruptions fill the stratosphere with ash and dust, less light penetrates. The umbra grows darker, eclipses dim to almost invisible, and the moon becomes a faint ghost. After Krakatoa erupted in 1883, observers wrote of lunar eclipses so black that the moon seemed erased from the heavens. When the skies are clear, the umbra is lighter, the moon glowing bright copper. In this way, every eclipse is a report card on the health of Earth's skies, an atmospheric diary written across space. Modern science uses this effect with precision. Instruments measure the brightness of the eclipsed moon, quantifying how much light passes through the atmosphere. Spectroscopy reveals not only volcanic dust, but the signatures of gases: ozone, water vapor, carbon dioxide. Each eclipse provides data on how Earth's atmosphere has changed, offering records that stretch back centuries when combined with ancient descriptions. What once seemed an omen is now a tool for climate science, revealing that Earth and Moon are bound not just by gravity, but by light. Even the shape of the shadow holds secrets. By watching how Earth's umbra sweeps across lunar craters, astronomers confirm the planet's roundness, just as Aristotle observed more than 2,000 years ago. The curve of darkness across the moon is always circular, no matter where the eclipse occurs, proving Earth is a sphere. Subtler measurements even detect that Earth is not a perfect sphere at all, but slightly flattened at the poles, bulging at the equator, its rotation written faintly in the geometry of shadow. And over immense timescales, this shadow is shrinking. As the moon drifts farther from Earth, the apparent size of our planet's shadow at lunar distance decreases. Today, it is large enough to engulf the moon completely, but in the far future, total eclipses may become rarer. The cone will still stretch 1 million miles into space, but the moon, wandering outward, will slip closer to its edges. Shadows that once enveloped it fully will only brush against it, turning today's fiery spectacles into faint and partial events. Thus, the blood moons we see belong to a special era. They are neither too frequent nor too faint, their shadows neither too large nor too small. They are a balance, a coincidence born of distance, size, and tilt. The shrinking shadow reminds us that nothing lasts unchanged, not even darkness. Each eclipse is both fleeting and eternal, a moment when the shape of Earth, the state of its skies, and the distance of its companion all converge to paint the moon in crimson light. In that glow, we see not just the shadow of Earth, but the delicate balance of a living world casting its breath across the heavens. To watch a blood moon is to witness both the present and the future. The geometry that aligns sun, Earth, and moon is not random. It is governed by laws that allow astronomers to predict eclipses thousands of years ahead. With the mathematics of orbital motion, humanity has mapped the crimson moons of centuries to come, charting their rise long after our cities crumble into dust. Each eclipse on that distant calendar is a promise, an appointment between light and shadow already written in the sky. Computer models reveal astonishing precision. Astronomers can name the exact date, time, and location of eclipses that will occur 10,000 years from now. They can tell which continents will fall beneath the spectacle, how long the moon will spend in shadow, even how bright or dim its glow will appear depending on Earth's atmosphere. The same gravity that binds oceans and pools tides guarantees this reliability. To predict an eclipse is not to guess, but to follow the mathematics of inevitability. Yet even inevitability evolves. The moon's steady retreat of 3.8 centimeters per year changes the scale of the show. Millions of years from now, eclipses will not look as they do today. The moon, smaller in Earth's sky, will pass through the umbra more quickly. Total eclipses will shrink in duration, and many will become partial. Farther still in the future, the moon will drift so far that Earth's shadow will no longer fully cover it. The great crimson spectacles will fade, leaving only faint grazes of shadow across lunar rock. And yet, for the foreseeable millennia, eclipses will remain abundant. Predictions show families of Saros cycles extending across ages, each series lasting more than 1,000 years before giving way to new ones. Some will produce eclipses visible across vast regions, bathing billions in the same red glow. Others will be partial whispers, seen only at the edges of continents, but all will belong to the same cosmic rhythm, a metronome keeping time across generations. These future eclipses will not only be moments of wonder, but tools of discovery. Already, scientists use eclipses to study Earth's atmosphere. Future observers may use them to study climate change centuries hence, reading volcanic eruptions, storms, or even human industry in the tint of crimson light. If life survives long enough to look back, they will find in eclipse records an archive of atmospheric history, preserved not in parchment or stone but in photons refracted through air. Perhaps one day observers will stand on the moon itself. From that vantage, an eclipse looks utterly different. Instead of a red moon, astronauts would see Earth turn into a dark disk surrounded by a fiery halo, sunlight refracted through the atmosphere, glowing like a ring of fire around the planet. Future civilizations may watch such sights from lunar colonies, photographing the glowing Earth eclipsing the sun, while back on Earth, billions see the moon turn red. Both views are parts of the same geometry, two perspectives of one cosmic event, and beyond the moon, even distant worlds may echo this phenomenon. Astronomers studying exoplanets around other stars already use the principles of eclipses to study alien atmospheres. When a planet passes in front of its star, starlight filters through its air, revealing chemical fingerprints just as Earth's atmosphere paints our moon red. The lessons learned from lunar eclipses may one day help humanity discover life on other worlds. Thus, the future of eclipses is not only about beauty, but about knowledge. They will continue to inspire poetry, to connect cultures, to gather crowds beneath darkened skies. But they will also remain instruments of science, windows into atmospheres, tides, and time. Every future eclipse is already scheduled, each a chapter waiting to be read. And yet, while the timings are certain, the witnesses are not. Who will look up? Who will tell the story? In the promise of future blood moons lies both the permanence of cosmic law and the fragility of human presence beneath the shadowed sky. Every blood moon carries within it a quiet truth. One day, the eclipses will end. For billions of years, the moon has slipped into Earth's shadow, glowing with borrowed fire. But this performance belongs to a temporary chapter of cosmic history. The geometry that makes eclipses possible is fragile, and slowly it is unraveling. The reason lies in the patient drift of the moon. Each year, tides on Earth push our companions slightly farther away. The process is imperceptible within a lifetime, yet relentless across the ages. As the moon recedes, Earth's shadow narrows at lunar distance. Total eclipses, once long and dramatic, will shorten. Copper light will linger for fewer minutes, then only seconds. Eventually the moon will pass too far to be fully swallowed by the umbra. Partial eclipses will mark the transition until finally the geometry collapses and lunar eclipses vanish altogether. This fading will unfold long before the sun becomes a red giant and swallows Earth whole. Perhaps 1 billion years from now the last blood moon will rise, a faint ember glowing briefly in the night. It will be watched by whatever minds or machines remain, a final crimson whisper before the curtain falls. That eclipse will not announce apocalypse but inevitability, the end of a coincidence that once linked Earth and Moon in fiery alignment. And yet knowing this gives present eclipses greater meaning. We live in the rare window of cosmic time, when Earth's shadow still engulfs the Moon completely, when the geometry is exact enough to paint it in copper light. Billions of years ago, the Moon was so close that eclipses lasted entire nights, dominating skies over seas where life had barely begun. Billions of years ahead, they will fade into memory, shadows too small to touch the wandering Moon. Only now, in this narrow age, do they appear as they do, fiery, dramatic, balanced between rarity and frequency. For humans, the last eclipse is not only a distant prediction but a symbol. It reminds us that nothing, not even the heavens, is eternal. The orbits shift, the shadows change, the sky evolves. What feels timeless is part of a story with a beginning and an end. The blood moon is beautiful not despite its impermanence, but because of it. Its glow tells us to look while it lasts, to wonder while we can. Perhaps by then, humanity will be long gone, or scattered among stars, recalling the red moons of Earth as ancient memories. Perhaps civilizations will rise after us, beneath alien skies, discovering their own eclipses, their own shadows painted with light. Or perhaps silence will reign, and the last blood moon will glow unseen, a final performance for an empty stage. But tonight, eclipses are still with us. The moon still turns red in Earth's shadow, still carries our atmosphere's breath across space, still unites billions beneath one sky. The last eclipse belongs to the distant future. The present eclipse belongs to us. And so the story closes, not with fear but with gratitude, that we live in an age where shadows still dance across the moon, where crimson light still glows, where the universe still pauses to remind us of its precision and its poetry. The last eclipse will come, but until then the sky continues to write its crimson verses, one blood moon at a time.